Alright, we got another one from the junk pile work and another 2510 saved from the scrap bin. I had to throw a single LED in here to light this up a little bit. It's orange. Orange LEDs are almost the factory color. Anyway, so I just tossed one in so I could see what I was doing. And let me explain how I found the problem, because it took me several days. It was pretty arduous. So okay, so we had no transmission, right? No output. So here's what we do. You go back to the schematic where you have your final. Okay, where are we? You got your final. You got the transistor before that and that and that, right? So you check the output on the collector. You check it. You put a scope on it. You can follow it with your voltmeter. There's charts in the manual to teach you how to do that, and you check and you see what you need to see here. The signal's there, the signal's there, and the signal was here, and then it stopped. And I was like, wait a minute, what's the story with this thing? Actually, I take that back. It didn't go here. It went through to here and then stopped. I could see the signal come, AC signals go through capacitors, and I saw it here on the base of the transistor. That's the on-off pin for this transistor. I could see it here, but I didn't see it across here. I got no signal, no output. So, most people go, oh yeah, man, the transistor's bad. Yeah, these transistors are getting a little old and a little hard to find, so you don't make those assumptions. So I was getting no signal here, which means I was getting nothing here. I got nothing on the base. So the problem was from this base going this way was where the problem was, right? And I couldn't find it, and I couldn't find it. I'm pulling the caps out and checking it with my meters. They're fine. I'm putting them back in. And I'm like, what the heck's the problem here? So I go over to one of the alignment procedures, transmitter, and you don't align it, but what you do is you look at the process. They're asking you to remove the circuit board from the main PCB, which is this board right here. It just slides right out. And then there's 3 test points that clip onto that board. So between test point 4 and 3, you measure 50 milliamps and you use VR12 to adjust for it. And then you go 4 to 2 and you do 50 milliamps and you use VR113 to adjust it. So here's what I did. I'll demonstrate this. It's pretty simple. It just pulls out. Don't bend those 3 clips or do anything with them, but just pull that out, set it aside. So when I was measuring from here to here on my current meter, this is the adjustment for it. It was like 20 milliamps. Well, the spec says 50. I cranked this thing all the way to one end to the other, and I couldn't get past like 30. I said, okay, there's something wrong. Now, these 2 and this are for the final. This one also has the same kind of current adjustment. It uses these 2 pins, and let's see, did I get that wrong already? It's these 2 for this one, and these 2 for this one. So you put the current meter across here, and you key up the mic, and I didn't get anything. I got 0 milliamps. This one was showing low, 20, 30 milliamps. This one was showing 0. So I went, okay, we got no current. Well, I went through a lot of iterations, but if you look at the circuit board here that I pulled out, you got to look where the power comes from. Test point 4, the power goes to 13.8. We can, just trust me. This pin, this trace right here is 13.8 volts. So I was getting 13.8 here. So then it has to get transferred from here to here and to here. It's just basically a fancy jumper so you can measure current. But that's all it is. It's just a fancy DC jumper. So what happens is you want 13.8 volts to go from here and to this section, the pre-driver before the final. You want to make sure there's power getting to the coil, and I did that. Oh yeah, we got power. And then I took this one, and the power comes up, goes through this side of the, let's just call it a coil for now, and then to the transistor. So the pin 3 collector, there was 13.8 volts there, and this one, there was a pin 2 collector, there was 13.8 volts there. Well, that's good. There's 13.8 getting where it's supposed to go. That, that's useful. The next problem was one had, let's see, the final had zero current, zero bias current, and this one was the one that was low. So I was like, man, what in the heck is wrong with this thing? So I spent a lot of time troubleshooting all these components in here, and it's 30 years old, caps go bad, pulled that one out, pulled that one out, pulled that one out, I also pulled out this one, checked them all, they're perfect, so I put them back. What happened over here is I got a little desperate, but I learned something from it, okay, so it was worth it. I don't usually throw in transistors. I find the problem. Well, the one that had zero current, I pulled out a spare final from another junk radio, put it in here, and all of a sudden the one that had 20 to 30 milliamps was now really high. It was, it'd do 100 milliamps if you wanted. I went, oh, well, so the final was bad. This one still had zero. Excuse me, my throat's dry. So what I did to try and find this problem is now I got current, and the pot adjustment here is making a difference on the final. Yay, that's good. Because as it turns out, the power that goes here goes through this inductor and through the transistor. That 50 milliamps that the spec calls for has to go through the transistor. So it actually has to go through a lot of things, but if the transistor is open circuited, it won't go through. And so I was getting some current, but not enough. Obviously not enough. So I started hunting around. Okay, so this one had better current after I replaced the final, and I replaced this one too, and it didn't change anything. I still had zero bias current, zero. So I said, all right, well, something's not here, something's not operable. So one of the tests that I did was, you see this diode here and this diode here? Those diodes are the temperature sensing diodes on this extra circuit board here and here. What happens is if they get too hot, it throttles down the transistor a little bit. So I checked across the two really fine wires. Let's see if I can show you one of them. See the fine wire here and the fine wire over there? You put your ohm meter across there, and it's supposed to be 600 or 700 ohms. Because, this is important, I know this gets old and boring, but part of this is I want to document what I did so I can look at it again in the future. If you look at the diode here, and what I was getting was 2.5 megohms. That's way too high. It's supposed to be 600 ohms. Well, so as it turns out, you got ground, you go through the diode, you got one pot, resistor, resistor, another pot, and ground again. So essentially, all of this is across in parallel with this diode. That's where the 600 or 700 ohms comes from. You got a 1,000 ohm pot that's supposed to be, whatever adjustment it is, a 100 ohm resistor, an 82 ohm half watt, a huge resistor, and then another 100 ohm pot. So when this is all adjusted right, it ends up being about 600 or 700 ohms across this diode. Well, that's a hint. It's 2.5 meg was what I was finding, and so I figured, you know what? This is what causes this to be 600 or 700 on a good radio. I checked this on a good radio. And so I started checking one at a time. Is it making it from here to here? Yeah. To here? Yeah. To here? Yeah. To here? Yeah. With an ohm meter. To here? Yeah. To here? No. Oh, the pot's broken. Okay, well, this only shows 2 pins of the pot being used, but these pots are 3-pin devices. So there was a flaw with this pot, and I can almost show you what that flaw is. Okay, so what happens is, this is the pin of the pot. Here's the center wiper and here's the other pin. There's no connection. If you take an ohm meter and put it from here to here, you're going to get, a few hundred ohms. From here to here, you're going to get a few hundred ohms. If you put it from here to here, you should get, this is 102, so that's a 1, a 0, and the 2 means 2 more zeros. Okay, so that is 1,000 ohms. So from here to here should be 1,000 ohms. Nope. From here to here was 0, or not 0, it was open circuit. Oh shit, that means it's a bad part. I did the same thing on this pot. This is 1, 0, and 1, so that's 100 ohms. I checked from here to here, it's 100 ohms. Check from here to here, it was some, 40 or 50, and from here to here it was like 30 or 40. So this pot was working fine. This one had an open circuit. Well, as it turns out, this pin isn't used. It's not connected to anything. It's soldered to the bottom of the board for mechanical support. So since this is open circuited, and what I found is it's impossible to see. I wish I could get it under a microscope, but there's a scratch right across the carbon track here, and it disconnected this from the carbon loop that's on here. So what I did under the board is I jumpered it from here to here, and now we're using the other half of the pot. Remember, it's 3 pins. There's a pin right here under the board, under this thing, and these 2. So it was using these 2. I rewired it to be these 2. When this is adjusted right, it's usually rotated way up here, the tip is, and you can see it's rotated way down because now it's been basically reversed. So I didn't have a spare one of these. My my junk unit, if you can believe there is such a thing as a junk 2510, it was already been taken out, so I fixed it. That was it. It was the stupid pot. Wasn't any of the caps. That's what it was. I just about lost my cookies, so I'm going to go to a restaurant and celebrate and have a nice meal. So anyway, once I found the problem, then I went through here and set this up to 50. These were both really far off, so you set one and you set the other, and you got to go back and forth until you narrow it down. So each one is 50 milliamps, and once you do that, then your bias for your transistors is set up about right. And so it took me a while to get them right, but it worked out perfectly. So one of the tests that I'll remember in the future when I get a radio that doesn't work or have any output is this board here, this circuit board that measures, basically changes the bias current based on this diode in here. You measure across those wires, and you should be getting, on this transistor, the pre-driver, you should be getting about 600 or 700 ohms. On this one, did I forget? On this one, it's, I think, 8 ohms, because it goes across something else. But those are still useful tests. That just takes an ohm meter. This one across here was 2.4 mega ohms, 2.4 million ohms, not 600 or 700. So when I started getting around here, I knew I was close, but I didn't know why. Was this blown up? What was blown up? So anyway, it was a 2-part failure. As far as I know, this final came out of the junk radio, and it cured half the problem. This was damaged, this trim pot, and that was the other half of the problem. So each transistor had an issue. This one was burned out, and this one didn't have any bias current. So there was no output. Anyway, so it works. I'm thrilled to death. I'm going to put this back in here. Now this has been tweaked. I need to double check my bias current, which I did like 3 times, but this thing's putting out like 40 watts peak. So anyway, it's fixed, and it was a mother. So I used the schematic, and I used the alignment procedure for the transmitter, and that's what got me there. I only needed to get this far, and I already had found a problem. 113 here had no current, 0. So there was something broken, and this one was way low. So something was weak, and that's how it worked out. I'm half tempted to put the final back in this radio and see if I can get the current back up, but probably not. Because I put the other one in, and all of a sudden, from 20 to 30 milliamps, I could do 300. So I think this one's good and the other one's bad. And the other one wasn't shorted. I don't know these transistors well enough to know if they fail shorted or fail open or what. But anyway, right now I need to go eat, so I'm not going to do any more screwing around. Yeah, two-part failure. The final was, I believe, weak, and that pot was damaged. And I don't see why, but I think I see a very fine scratch, and it went across the carbon track and opened the circuit. I'm not a big fan of open frame trim pots. They get dirty. You know, here they can fail because it got scratched. I don't like them, but you know, I'm not the board designer, so they probably saved a nickel a piece or 20 cents a unit, so they saved some money. Anyway, this bad boy works. It's got several other problems. I mean, this thing was in the junkyard big time. Had no knobs. I borrowed these off another radio. Had no knobs. The channel knob didn't work, so I had the junk one. I put it in the whole unit, and that fixed that problem. I still have, I think it's the lower channel button doesn't work, and I've already rebuilt one of these, so I got to take this whole thing apart and fix that one. When I checked everything on the 1200S, I got audio and carrier for AM and FM. I got a carrier for sideband, but the audio was really messed up. So that's got to be, you know, dialed in and tuned or whatever. The other thing that's wrong with this thing is the plastic here where the two screws go is gone. It's snapped off and missing in action. So I just taped it together so I could troubleshoot this radio. I mean, it was a total junker, man. It was going away. But it works now. And now it's a matter of getting knobs, and you know, I'm not sure how I'm going to fix the face of this. That's not a priority. You know, I've got stacks of these things to fix. See that? Stacks of these 2510s. And then a whole bunch of processor boards to fix. So I'm just going to leave this because now it functions. It's roughly tuned. One of the things I did notice is it's a 1 kilohertz low. It's 1,000 cycles, 1,000 hertz low. So you dial in 28.000 and it shows on the meter, on that frequency error meter, that it's low. So it needs tuning, whether it's the PLL or the RF out here, I don't know. But it doesn't matter. The whole point was it went from junk to functional, and yes, it needs to be tuned, which I'm going to do to all the radios at the same time. I'll tune them one at a time. So I make sure I get the process down really well. All right, well, this bad boy works. I can't tell you how happy I am. The last video I did of a junkyard 2510, it wasn't as bad as this one. This one is the worst so far, and I have another one that's pretty bad coming up one of these days. So anyway, I just wanted to show you guys. I've really fallen in love with 2510s, and I just can't let them go in the trash. I just can't do that. So we do have a junk one that had a lot of parts missing before I got a hold of it, and I only made it worse. But it's made 6 other radios functional, so it was kind of worth it. Sacrifice one for 6 radios. I think that's okay. Anyway, it functions. It has great output, 40 watts on AM peak. It dead keys, I forget, 3, 4, 5 watts at dead keys. Anyway, that's it for now. We got another one going. I'm thrilled to death. This one was hard. This one took days to figure out. I went through it real quick because that's what happens after the fact when you fixed it. All right, that's it for me. Gotta go eat. See you. Bye.